Welcome back. So we are going to go through 5.2 angles and sides of triangles. So in 5.1 we talked about angles, and now we're talking about not only angles but the angles and sides of triangles. So in 5.1 we talked about right angles. Now we've got a right triangle, which I'm going to define here. A right triangle, as you can see on the right hand side of my slide here, it is a triangle that contains a 90-degree angle. So it's just a triangle that has a right angle. A 90-degree angle. And just like the right angle with the right triangle, we also indicate that this is the 90-degree angle or the right angle by putting that little box. All right, so moving on to the next one. Let's format this real quick here. Moving on to the next one. This is an obtuse triangle, and we talked about an obtuse angle in the last section. So an obtuse triangle, well, take a look at this angle right here. What kind of angle is that? That is an obtuse angle. So a triangle that contains an obtuse angle. So right triangle has a right angle. Obtuse triangle has an obtuse angle. Now you might look at this and look at the other two angles, and what do you notice about those angles? Do they look obtuse? Well, no, they're smaller than 90 degrees. So those two are acute. It is not possible to make a triangle with more than one obtuse angle. If you think about it, if you have one obtuse angle and you go to make another obtuse angle, so another angle that's larger than 90 degrees, you would not get a triangle. So this, you'd have to have another side. That's four sides. It's not a triangle. So you have one obtuse angle and an obtuse triangle. The next one is an acute triangle. We talked about an acute angle. An acute angle is an angle that's less than 90 degrees. Remember, it's a little cute one. So now an acute triangle, we'll take a look at these angles in this triangle. You have an acute angle here, it's less than 90. An acute angle here, that's less than 90 degrees. 90 degrees would be straight up and down right here like the corner of a paper. And you have an acute angle here. So we have three different acute angles, and they're not all the same measure necessarily. They could be. In this diagram they just don't look like they are, but we have three acute angles in an acute triangle, so none of these can be obtuse. If any one of these is an obtuse angle, then it would be an obtuse triangle. But since all three are acute angles, this is an acute triangle. So a triangle with three acute angles is an acute triangle. On the next one, I put a picture of a house with a whole bunch of icicles on it. I don't know if this is going to help you, but it helps me remember that an isosceles triangle kind of sounds like icicles. And I think of this as like the roof of a house. And I've got little icicles hanging down. But these in this lesson are obviously not icicles. These tick marks here represent congruence, that these tick marks show that these sides are the same length. So I'm actually going to write that in on here. Let's type this here. The tick marks represent that the side lengths are congruent, i.e. the same length. All right, so that's what those tick marks imply. But in order to be an isosceles triangle, we need to have at least two congruent sides. So I'm going to put that over here. An isosceles triangle, a triangle with at least two congruent sides. So that term right there, at least implies that many or more. So two or three of the sides could be the same length. Obviously, a triangle can only have three sides, so you could have three, but only two of them have to be congruent in order to have an isosceles triangle. All right, a couple more to go. Looking at the next one, it says equilateral. Equilateral. If you break this down and look at the prefix of this word, it says equi, which implies equal. This means equal. Then you have the word lateral, like side-to-side movement would be lateral movement. So this is equal sides. So a triangle with equal sides. And if you look at the diagram over here, it's got three tick marks on it, which implies that all of those sides are congruent. So an equilateral triangle is a triangle with three congruent sides. Triangle with three congruent sides is equilateral, equilateral, equal sides, equilateral. The next one is similar. This is an equiangular. Equiangular. So again, equi or equa is equal. Equal. But now this is angular. So this does not mean equal sides. This means equal angles. So an equiangular triangle is a triangle with equal angles, meaning all three angles are congruent. So a triangle with three congruent angles. Now, just to make a point about these equiangular triangles, if all three of the angles are the same, and the interior angle sum of a triangle, meaning if you add up all the angles in a triangle, you get 180 degrees. So let's say this is x, and this is x. Since they're all the same, we'll call them x degrees. So these are all x degree angles. Well, if I add up all of those x's, x plus x plus x is 3x. Well, as I just said, when you add up all the angles in a triangle, you should always get 180 degrees. So when you add those up, you should get 180. If you divide both sides by 3, you get that x is 60. So in this equiangular triangle, all of the angles must equal 60 degrees. All of these are 60 degrees in an equiangular triangle. One more thing that I do want to mention, actually about the isosceles triangle. On the isosceles triangle, there's a property that says that if these two sides are congruent, then the angles across from those congruent sides are also congruent. So these angles across from the congruent sides are also congruent. So let me make a note of that on this slide as well. So I'm going to say that this is a property of isosceles triangles. Isosceles triangles. So as I said, the angles opposite of the congruent sides are also congruent. So if you have any sides in a triangle that are congruent, the angles across from those congruent sides are also congruent. So what that would mean for the equiangular triangle is that the side lengths across from all of these are also congruent. So in the equiangular triangle, it is automatically also equilateral, and then if you look at that the other way, these are all congruent, so the angles across from all these must be congruent. So if it's equilateral, it must be equiangular. So anytime you have an equiangular triangle, it's automatically equilateral, or if you have an equilateral triangle, it's automatically also equiangular. All right, so let's keep moving. We've got one last one to go, a scalene triangle, and a scalene triangle is a triangle where no sides are congruent and no angles are congruent. So that just means that nothing is equivalent. No side lengths are the same length, no angle measures are the same measure, and that's a scalene triangle. So there you have it. That's a lot of vocab. So we started with a right triangle with a right angle, a 90-degree angle. An obtuse triangle has one obtuse angle. An acute triangle has all three acute angles. Isosceles triangles have at least two congruent sides. Equilateral triangles have all equal sides. Equiangular triangles have all equal angles, and scalene triangles have nothing that is equivalent. No sides nor angle measures are equivalent. All right, so let's use all of that as we go through some examples here. And there's only two examples. The majority of the section is applying vocab. So this says, find the measures of the missing angle. Find the measure of the missing angle. So we're trying to find this right here. And classify the triangle in as many ways as possible. So when it says classify, that means we're going to look at all of our vocab and try to explain how many different ways we can classify this triangle. All right, so let's start with finding this angle measure. So as I said before, the interior angle sum of a triangle, when you add up all the angles in a triangle, you get 180 degrees. So in this one, if I have x plus 60 plus 60, I get out 180 degrees. So let's solve this equation. Combine the like terms on the left, we get x plus 120 is 180. Subtract off the 120 from both sides of the equation. That cancels out on the left, and we end up with x equals 60. So x is 60. This is 60 degrees, which we should have actually known that already because we have equivalent side lengths. This is an equilateral triangle, so the angles across from the side lengths that are congruent are also congruent. And since these are congruent or those are congruent, the angles opposite of them must also be congruent. So we should have just been able to realize that should be 60 degrees. But I wanted to show you how to find it algebraically as well. All right, so let's classify the triangle in as many ways as possible. So for the classifications, you have to think back to all of those notes. So is it a right triangle? Well, does it have a 90-degree angle? No, so it's not a right triangle. Is it an obtuse triangle? Well, no, because there's not one obtuse angle. So this triangle is an no, I'm going to start with acute. Is an acute. It's acute because all of the angles are less than 90 degrees, so it's acute. Is it isosceles? Remember, an isosceles triangle needs to have only or at least two congruent sides. So do we have at least two congruent sides? Well, yeah, all three of them are congruent. So this is an acute isosceles. Anything else? Well, let's think of the other ones. We have an equilateral triangle. Do we have all three sides being congruent? Yes, so this is also equilateral. And then if it is equilateral, that automatically implies that all the angles must be congruent, which we proved that, yes, this is also congruent to the other two. So it's also equiangular. And then is it anything else? Well, let's see. Is it a scalene triangle? Well, it's definitely not scalene if it is equilateral or equiangular or isosceles, because for it to be scalene, nothing could be congruent. No sides nor angles could be congruent. And we definitely do not have that in this case. So this triangle is an acute isosceles equilateral equiangular triangle. And there are all the classifications. Example number 2, find the measure of the missing angle and classify it in as many ways as possible. So we're doing the same thing as the last one. So we need to find the measure of the missing angle. So we're trying to find the measure of this. And again, if we add up all the angles in a triangle, they need to equal 100. Their sum needs to equal 180 degrees. So x plus 30 plus 40 must equal 180. So solve this just like the last one. Combine your like terms. You get x plus 70 equals 180. Subtract 70 from both sides of the equation. And that will cancel out the 70s. You will get x equals 110. So this angle right here is 110 degrees. All right, so let's classify it in as many ways as possible. So again, I'm going to say this triangle is, and now let's see, let's start from the top. Is it a right triangle? Well, no, because we don't have a 90-degree or right angle. Is it an acute triangle? No, because we don't have all acute angles. Is it obtuse? An obtuse triangle? Well, yes, because we have one obtuse angle. So is an obtuse, let's see if it's anything else, or is it just an obtuse triangle? Well, let's keep going through our list here. Is it isosceles? Well, none of the angle measures are the same, which implies that none of the opposite sides from those angles are congruent. So if, let's say, this was a 30 and a 30, then the two side lengths across from those 30 degrees would be congruent, but it's not a 30 and a 30, that's not a 30, so that does not work. So we don't have any of the side lengths being the same. So this side across from the 40 degrees must be different than this side across from the 30 degrees, and this side across from the 110 must also be different. So all three sides are different, and all three angles are different. So that tells me, since all three sides and angles are different, I'm going to say this triangle is an obtuse scalene triangle. So it's scalene because none of the side lengths and none of the angle measures are congruent. So this triangle is an obtuse scalene triangle. And that's it. That's all I had for this lesson. So your assignment is a book assignment. I'll be sure to put the book pages on Google Classroom, but feel free to use your textbook if you brought that home with you. Have a good day.